Okay. First of all, just two, three. Yesterday, when we are creating the index over there, the index was properly created, but it was not been populated or not been showed in the visualization over here. But after few minutes, I checked it, and the index was been fine over there. Okay. So let me quickly show you. So just a quick recap. Actually, whoever is joining new over there in this class. So we try to create index. So we are doing an indexing on a particular table. So suppose I think we have started the indexing on student table. Okay. So in the student table, we create the index, but the index, it was not been shown over there. How to check the index? Just like table inspector, indexes. Yes. So this is the index, and you can see on top of standard and roll number, we we have done the index yesterday. Okay, so this is the index value actually. IDX student standard or just like this. Standard roll number. So it was fine and that was also been created yesterday, but we're not able to see due to some reasons at the software side. We closed the software and opened it and I'm able to find the index over there. Okay, so there will no need to worry about that. It's fine. So we can also create the index from our command prompt. By the DDL, create index, particular index name on table name within bracket particular column or set of column you can put for in the for the index. Okay, just like let me drop this index. I can drop the index, just like drop index name, or I can also select this thing and drop index from here as well. Okay, anything drop index will be helping us in this way. Dropping the index from the entire table. Okay. Okay, so there is some one more hands-on exercise is available. It was available there. The second problem. Did anybody try this thing? Can I just go through this topic or? Okay, let me cover up this thing. Actually, today we have much more time. Okay, it's lost the connection, but it's a simple way. You can delete or drop the index in this way. Sometimes it drops, the connection maybe for connectivity issue with the database and the index and but this is the way we can create and drop the thing. Okay, so I'm directly moving forward with our second problem. Then we can start today's session. It's generally on business intelligence. Or should I start it after finishing off this thing? I think we will be having some time. Then we can go ahead with the second problem. Okay, I think that should be the better idea. Let's cover up the session for today. Today it's a new topic. SQL we have finished or completed, we can say. Okay, let me have my volume. Okay, so business intelligence. So whatever we are doing in the data engineering part, so the overall things. Why we are doing this? Because we are doing this part as as a subset of a business intelligence. We can say over here. Okay, so what is business intelligence now? Business intelligence is required in every business as of now. Nowadays, every particular industry, they're owning this kind of intelligence property at their own business. Why this is, so much important? I think I have already told you in a particular introductory class there. So um, we can handle the data, whatever data at the transaction level, the business can collect it. The same data can be analyzed, and we can get suitable patterns of the uh, what the data is going, just like forecasting the business, revenue of the business. So this kind of graph we can quickly create by the insight of the data. We cannot directly take the source data. We have to prepare the source data to the meaningful data. So that conversion of the meaningful data, data engineers can help. the business team. Okay. So in this chapter, for the today's session especially, we will be creating those meaningful data and we will be storing the data in data warehouse. Okay. Then the visualization team, they are also doing kind of data engineers part as well. So the visualization team, on top of meaningful data, they can create those chart and graphs. And then the decision owner, who is from the business side. Okay. So the business owner or decision maker, whatever we can say, they can take the graphs, charts, they can get the hidden pattern or hidden trend. Okay. To improve their business, they can take easy decision on top of those analytical graphs. So why the data engineers are important now? So they will be helping the business. They will be helping the business growth by creating those meaningful data as well as the visualization stuffs properly. They can also do the data analytics part. Even the data angel, they are a data scientist as well. On top of meaningful data, they can also create their logic at their side. They can create the probability of a particular what should be the forecasting of the business, how the revenue should be there, what are the changes required to have a greater revenue in the next quarter. So these kind of stuffs they can quickly decide. So that is the importance. For the business intelligence only, the data engineers are required nowadays for every project. Okay. So let me go through the first topic. It's fine. I think hopefully everyone has joined over here. Most probably. Fine. Let me get started. So today, it's not very much technical. It's a theoretical one, but you can also get lots of questions. If you are just going ahead with the data engineer interview or anything. So business intelligence is one of the more, not one of them. It's the main thing. That's why the data engineers are existed for this business intelligence. So it's totally theoretical and some conceptual as well. And we must have the knowledge. Otherwise, if we are just already entered in a particular business intelligence project for the data engineers, then lots of terminology is there. Just like some table can be considered as fact table, dimension table. We need to create those stuffs at our own. So this terminology is required because of when we'll be receiving our work from our team lead or any our project manager, we need to understand those terminology and why this is required. If the question is why, the reason is business intelligence only. Okay. So let me give a entire scenario, then I think that should be helpful. Over there, what I have done over here, suppose I am owning a shopping mall. Okay. And the shopping mall is having multiple outlets in multiple cities. Okay. So, uh, in the shopping mall, you can see that, I'm collecting the data, collecting the information in computer while doing the billing part. Okay. So the same, each of day's data, the billing parts data or the transaction can be saved or can be stored in any hard disk over there on that day. And at that, when the transaction is over for that day, there are some jobs or something, some process was there which will be converting the data, which will be transferring the data into some BI application. Maybe it's a night process because our transaction is over for the day. And in the overnight, we will be, the BI application do all the calculations. They will be refreshing the tables and then meaningful data can be received by this way. Okay, it's not a single days data. Not for single days. Daily, it should be happening, and daily basis we can check our business growth or business strategy. You can change the thing at your own. If I'm the owner, I can change the strategy. Okay, so just like we are collecting the sales data from different mart or different outlet, and through BI application, we can we can answer what are the questions over here, just like sales in the previous quarter. revenue growth in the last 5 years, best selling product for this season, this kind of stuff. I already give you an example. Suppose I have a low performing product, okay, very low for a particular outlet only. Suppose this outlet, a particular product is not being sold, okay, but we are keeping this thing over there day by day until the store manager or anyone told me, sir, your product is not, this product is not been sold. Please do not send it. So I need to wait this kind of stuff till the store manager will tell. Otherwise, it will be, I mean, they will be stocking it daily basis. Okay. But if we check this kind of graphs at our own, we can quickly check it. The graph should be also there for the on top of product. The on top of product, how many sales is there? The average sale. What is the thing? If I quickly check a graph on top of that product, what is the sales? And we can also quickly check it the hidden pattern from the graphs itself, that this particular product is not been sold over I mean that particular outlet, and it's having very, I mean the profit is going diminished, or it's going, I mean getting reduced for that particular product only. Okay, because we are manufacturing it, but there is no uh, no profit from that product. So as the decision maker, what I should do, I have to remove that product from this outlet, or maybe keep one or two, uh, products for that one, for safety purpose. If someone wants to buy this thing, if I do not have that one, so I can minimize that stuff. Then I can check if any outlets is having the same product purchase percentage or anything. If I have this thing, we can quickly transfer it. Okay, I can check, or I can do this thing overnight while doing the business strategy or business owning part. I do not have to wait till our store manager will check the stock for a 1 month or just like this. Okay, I do not have to wait for 1 month. So BI application will help this kind of stuffs. Okay, so data engineers will be working in the BI application side, and they will be just creating the data, the raw data that should be transactional raw data to analytics data. I'll be coming to these things in the later slide, so that can be easily understandable. Okay, moving on to the next slide. Okay, so this is the entire cycle. OLTP, that is the transactional data. What is OLTP? I'll be coming to this thing. Maybe the interviewer can ask, what is OLTP? Then by ETL, there is a process or arrow. You can see it's called ETL. ETL may be a tool, maybe open source languages, just like Python, which will load the data from source system, that is transactional system, to data warehouse. Data warehouse will store the meaningful records. Okay. Then the same data should be used for reporting layer that I told you. Maybe there are a variety of tools are available in the market nowadays, that is called Tableau, ClickSense, Power BI. Okay. So those tools will help on top of data warehouse or top of tables. They can build those charts and graphs. And after that, the decision strategy planning should be there. They can plan and they can take the decision, and the same decision can be reflected in the next day's OLTP. Okay, so suppose decision owner can check the particular graphs and charts, and they want a quick remedy, and they update, or they update the inventory. What should be the stocks, and how it should be modified, what should not be sold, what should be sold much more in nature in that particular outlet. So that can be reflect within a night, or within 2 or 3 nights after the decision has been made. Okay. So after the very next day, when the decision owner can check the next day's data after the strategy has been undertaken, they can check the improvement in the graphs and charts for that day only. Okay, because the past history day, it was not a good one, but for that day, it was coming with the growth of the business. So this is the overall cycle. Okay. Any doubt till now from anyone? This is totally theoretical, but very much interesting. And we will be working in this process, ETL data warehouse over here as a data engineer. I'll be coming with more deeper way inside how we are storing the in data warehouse and all. But if there is any stuck point, please feel free to ask. Okay. Someone maybe Bharadwaj or anyone who have already covered up this session, maybe in earlier season, then maybe it's a repetitive for you. But still, if there is any doubt, then please go ahead and ask. And just a quick, the last season we have covered up SQL, then Python. But I checked, or I think that yeah, it's a very much important one, the BI business intelligence part, because we have already done SQL and we have the concept on tables. Okay, so this is the enough thing we can just quickly learn, because uh, actually this particular course, I mean, there are two BI courses there. I mean, BI slides or BI deck is there. I'm going to deliver. So if I just cover this thing at the last, then there will be, I mean, the sync up with SQL and this thing will be less. So I'll be covering up this thing within 2 days. Then maybe at the Friday onwards, we can start up the Python stuffs. Okay. So Python over there we'll be using as a ETL tool. Okay. So Python will be helping us. It's an open source language. It will be helping us loading data from a source system and pushing it to a data warehouse. Okay. So I'll be just as we already learned what is table and all, so I'll be quickly covering up the data warehouse. Then I'll be coming to ETL part with the help of Python's example as an example. Okay. Okay. So going to the next slide. What's happening? Okay. So now what is OLTP? With the OLTP, we have also put OLAP, that is called OLAP. So first of all, what is OLTP? OLTP is Online Transaction Processing System. So whatever source data we are receiving from the source system, okay, so that can be, we can, I mean, those raw data can be stored in OLTP system. So what are the kind of OLTP? Just like bank transaction, if you are just going ahead with some banking transaction over there, railway booking and cancellation. So this kind of stuffs. What I mean, user can put their data in user interface. Suppose we are filling up some form for examination. So whatever we are filling it up, they are storing it somehow. Those are the online transaction processing system. So those are called OLTP. Okay. And we have another naming convention that is called OLAP, Online Analytical Processing System. So the OLTP information we are storing, and we are converting into meaningful data and storing it in data warehouse for analytical processing purpose. Okay. So just before we are pulling this thing in charts and graphs, we are creating in this way this analytical processing system. Those are called OLAP. The table which are ready for the reporting purpose, those are called that analytical processing system data, OLAP data. So this is the difference between OLTP and OLAP. OLTP is just like the source system data, and OLAP, the data where we are storing it, and the data is ready for visualization, ready for graph and chart preparation to discover the hidden trends and patterns. Okay, OLTP systems are designed to handle the complex query that are used to discover trends and patterns, and these queries are usually executed on data warehouse. Sorry, OLAP. Yeah. Okay. So going ahead with the next topic. Okay, just a quick introduction. What is decision support system? I already told you, and they should be mainly from the business side. Maybe the data engineers, they can be doing the thing from different company. Suppose I'm working in an insurance company. So I'm the vendor of this. I mean, of the one company. So the data engineers can be vendor or anything, but the decision owner, they should be from business side. They should be from their company only. Okay. So they can take the easy decisions based on sale. What is the sales for the distribution for region wise? Obviously, how much profit does a particular product contribute? Okay, this kind of questions they can check and make easy decisions over there. How did my revenue improve in last 5 years? Which channel cost we more, pay and less? So particular which channel we are, the costing is getting more and less. We can check this thing, and based on that we can choose the efficient way for the channeling and all. Okay. So those kind of questions may arise to the decision support system. They are also expertise. Maybe they have completed MBAs or some higher studies over there, and they can took the easy decision on top of the data. Okay. Maybe they are data scientists as well. So on top of data, meaningful data, they can do lots of things at their side to have these questions or to solve these questions at their mind. Okay. So moving to the next slide. So just like this one. So maybe we are receiving those kind of OLTP data. Okay. We are preparing this data with a meaningful one. And on top of this meaningful one, just like OLAP I'm telling about. So on top of this OLAP, the visualization team can create this kind of charts and graphs. Okay. So this is a dashboard screenshot. So those kind of charts and graphs, from checking these things, the decision owner or decision maker, they can take easy decisions. Okay. By checking the raw data, it's very hard to get a quick resolution of a business issue or anything. But if you can check it, if you can drill down with some graph, you can maximize the graph for a particular subject. So there is lots of features available nowadays in the tool. Okay. So by checking those kind of stuffs, the business owner can take easy decision. Okay. Moving to the next slide. Yeah, just this is the thing. World without DSS. Data is spread across the organization, but there is very delay to get a decision, or maybe, we cannot cover up easy losses within a minute or within a day or just like this. So those kind of, decision owner or DSS is very much important for a business. So they can take the easy decisions, but they are not from the data engineering perspective, but they are the one who can give us the decision or give us the particular direction how to prepare the data for their side for them. Okay, otherwise they cannot take the easy decisions. So even if we are working as a data engineer, uh, we need to obey some rules, or we need to check someone's decision or someone instruction from their team, decision on a team, or maybe business team. Those are also called business IT team, BUIT. So they can help us which kind of tables or source tables we will be picking up for our dashboard purpose. Okay, so they will be helping us lots of tasks. They are directly collaborating with DSS, and so actually the collaboration of DSS and data engineers plays the entire role for this business intelligence part. Okay, so not only the data engineers, they are also a key. They are playing the key role as well. But they are very much senior, having lots of experience in the data engineers as well. And maybe they have done, completed their MBAs and all, and they are in this position now. Okay, moving on to the next topic, data warehouse. So now we are entering inside the data warehouse. This is the data warehouse. I have already have the pictorial diagram earlier. So this is another kind of representation. So just like the transaction is, this should be in this level. Okay. So first of all, we are storing data in operational database. That is the OLTP, we can say. Okay. So extract data. This arrow is same as the ETL, and we are loading this thing in data warehouse. Okay. In tabular format. Data warehouse may be a particular database, just like MySQL, what we have learned. Okay. So it can be also operational database, OLTP. This database can be used in any purpose. But nowadays, there's lots of features are available for data warehouse. So we can choose some, very much efficient databases like Teradata, Redshift, Oracle as well, Snowflake. There's a database called Snowflake. So those kind of database nowadays, the architecture are choosing to have the storing of the data and MySQL as OLTP. They're not choosing MySQL as data warehouse. They're trying to choose it's a operational data. I mean OLTP, because data warehouse it should be good quality database, and it should be storing high number of. I mean that should be scalable in nature because the memory size would be big, and I mean it should be all time on live. They're not. There should not be. I mean it should be readily available to every stakeholders, from starting from the data engineers, data analytics, data scientist, visualization team. So they're choosing different databases. I mean, based on the number of, I mean, volumes of the data and number of transaction of the data after the analytics is prepared over there. So they can choose any kind of data warehouse, any kind of database to represent the data warehouse. Okay. So moving further. Okay. So how, I mean, the data warehouse, what is the data warehouse actually? I mean, we are storing the meaningful data in data warehouse, obviously, but the data warehouse should be subject oriented, of course, because I mean, suppose I'm working in a particular company, and in the company, in the same company, company has different sector. It is having medical devices as well as it is having some pharmaceutical stuffs as well. So I'll be not storing the pharmaceutical or commercial stuffs in the medical devices stuffs. So that's why the data warehouse is being splitted on top of different subject areas. Okay. So that's why data warehouse should be subject oriented. It should be integrated in nature. All the data should be integrated in nature. It should be time variant. Okay. So you can check the historical data as well. I mean, data warehouse, it should not be storing only today's record. It should be storing lots of historical days records. Otherwise, we cannot able to compare the old data. If you are quite aware of YTD, MTD, that is called year-to-date data. So maybe when I'm comparing previous year sales with this year, then we need to check this kind of previous years, all the months data for the last years. So that's why it should be, I mean, the data arrow should be having these characteristics that it should be time variant in nature. Non-volatile. Yeah, the data cannot be erased. I mean, if it's erased, then there should be lots of, I mean, what we can say, data breaches, or it should not be, it's not good in nature. I mean, somehow maybe for some issue from inefficient resource, they can drop the table from the data warehouse, but this is not acceptable actually. But nowadays all the database have the capability for the time travel. We can check quick instances what is there in within last 72 hours or last 30 days. If we tell the particular timestamp when the data get lost from the data warehouse, they can easily help us to picking this thing up. They can help us with the time travel. For that instance, we can roll back the database setup. Okay. So, but actually data warehouse should be non-volatile in nature, ideally. Okay. So moving to the next topic. Okay. This is the entire workflow architecture again. I have presented in a with a good pictorial representation. The same thing, the source system. So we are not directly pushing the data in data warehouse actually from the source system, or it's called the OLTP. We are moving into this thing in a staging area. Okay, it can be also a database, or it may be the same database with a separate schema. Maybe staging schema should be there. Okay, so after that, staging schema, we are just pushing the data without any transformation from source to staging. It's one-to-one mapped over there. So that is called the staging. After storing into staging, and the same, when storing the staging, when stuffs into staging, the transformation will be helping you. Sorry, no transformation will be there. The ETL will be helping you to pushing data. What is ETL? I'll be coming to this thing later. The blue arrows are ETLs. ETLs, okay, let me just quickly cover up. ETL is a, maybe it can be a tool, maybe it can be open source language which will be helping us with transferring the data from one system to another. Okay, the full form of ETL is called E for extract, T for transform, L for load. So there are lots of tools are available at the market for the ETL purpose. And nowadays, nowadays also the architect are preferring not to use the tools, rather use open source languages. There are Java, Pythons are available. On top of this language, we can create some framework. Okay, and in this framework, we can pass the parameter for each kind of table loading. Okay, there are lots of table actually at the source system. Should not be a single table at the source system. So all those tables can be loaded by the framework driven. Those language are maybe in framework, the Python or Java. So it can update the metadata for each of the table. And if we run the proper job at the ETL side, the data should be loaded from source to target. Okay. We have some other slide for ETL. We can discuss the same topic in later slides. Just a quick introductory part on ETL. Those are the stuffs. So the data is coming over here. After crossing the staging, we are cleansing the data. Maybe there are lots of wrong data or garbage value should be there inside the data. Maybe our record should be having trial spaces. Okay. So those kind of things will not be helping us while designing the graphs and charts. Maybe there are lots of null value, which should not be a good one. Maybe there are lots of duplicate value. So we need to clean those stuffs as well. The date format is not in good shape. So we need to make this thing. So cleansing and transformation we have to do over here in this process. And in the final steps, we'll be storing in data warehouse. Sometimes in data marts as well. It's the miniature of this data warehouse, data mart. Okay. So our ultimate goal is, over there ETL is also being used, and even in ETL inside we are cleansing and transforming the data within the requirement. What should be our proper requirement? We are doing the same steps in inside the ETL, and we are storing it for data warehouse. And over there the OLAP analysis should be there. Okay. Any doubt from your side, please? It's very conceptual as well. Okay, we learned what we learned till days. We are able to learn the tables inside the data warehouse. Okay, tables are the basic unit. So while doing the transformation or cleansing or any aggregation summarization, we can take help of this kind of just like group by cleansing. There are lots of cleansing functions as well on top of particular column length and all. Okay, so those can be helpful. So whatever we have learned in SQL, that is for storing the thing in data warehouse as a small unit of data. Or we can also say, even in staging area, we are storing in table, but the table is within the what is there in the source system. We are just copying and pasting it over here. So there is no changes, but entire steps from the data engineers, they have to design this kind of thing, cleansing the data, transforming the data, and do some aggregation or any other features or functionality that that should be in our requirement. We have to do the same thing before pushing it to data warehouse and data marts. Okay, moving on to the next slide. Okay, what is there's a just difference between ODS and data marts. Actually, ODS is not been taken for all the uh, even we can say all the business owner or all the projects or all the application. ODS can be removed. It should not be taken. They can directly take from staging area to data warehouse and data marts. Okay, ODS can be there, cannot be there. It totally depends on the decision maker or the business owner, BUIT, business IT team. Okay, so what is ODS? Actually, just for a quick introduction on ODS, an ODS, or it's called the operational data store, is a data store used to analyze near real-time data uh, just like you can say the live data as well. For day-to-day basis solving problems, we can use ODS. It's very fast in nature. And whatever, generally in the big or large system, whatever the transaction is there, that can be available in the very next day into data warehouse. Because in overnight, we are running the jobs, we are storing those transactions into meaningful data at the night time, and at the very next day, business can save, they can see what are the updated stuffs or data or analytics part at their end. Okay, so it's a 1 day gap, but generally ODS it's a very less in nature. The syncing up things is very less in nature, and they are just designed for solve day-to-day activities over there. Okay, and the data mart is the obvious thing. If we are using data warehouse, so data mart is a miniature of the data warehouse. And for each of the subject area or each of the focusing system, we are keeping those things inside a data mart. Suppose for banking system, we have created a data warehouse. In a particular banking system, what are the stuffs? Separate stuffs, just like credit, debit, uh, banking customers information, banking employees information. So based on those stuffs, we will be creating separate tables. Okay. So the bunch of those tables or the collection of those tables are called data warehouse, but each of the tables are called data mart. So that is the only difference. Data warehouse is the collection of all the data mart tables. Okay. And data marts are, based on those, each of the subject area, just like for credit transaction for today. Okay. So this should be stored in a table. That is the data mart. Okay. For this organization or this shopping mall, we can see top of this functional area, we are having sales data, finance data, marketing data. So for each of the particular subject area or this functional area, sorry, yeah. So we can we can say this is data mart, or we can store the data for the data mart. Okay, it should be focusing only a single subject area. Data warehouse can be used multiple subject area, but it should be not, banking with insurance company, not in just like this way. It should be only subject area, and data mart should be split with functional area. Okay, hope that is understandable. If not, please keep asking. Maybe I am too much first, or maybe I'm too much slow as well. Please tell me. Okay, so this is the same. I'm using this kind of stuff so very, very much over there because just to have a pictorial representation or diagram what we are doing actually. So those are different data mart. This is a insurance company. Okay, so we just remove the in between what we are doing. We are loading as a staging because we already know that thing from the previous examples. So this is the entire process, and we are storing the thing in data mart. So insurance OLTP, um, for insurance company, we are collecting lots of information. But while storing the data mart, it should be for a individual functional area, property data mart, automobile data mart, commercial data mart. Okay. So on top of that, the reports can be generated. Maybe with the combination of this OLTP, we can create the entire report, or maybe someone specific will check the property data mart. For them only, we can use only a single report. Okay, the report can be segregated. It's totally on the business decision. How much they will be checking. Maybe there are also hierarchical level at the management side. Someone only check property, someone automobile. On top of the particular decision owner who are checking these things, on top of them who is there, they will be checking a single dashboard containing everything. So they have the scope of action. Maybe if I'm the CEO of the company, I have to check entire stuffs, not only single reports over here. So my dashboard should contain all the stuffs. So there are lots of access control at the dashboard side as well. Okay, so we can control the section access. If I'm logging to this system, I have, based on the particular position he or she is holding, the particular charts or reports can be controlled by access. Okay, moving ahead with the next slide. Okay, now I'm inside the data mart. I need to, I mean, those are the all the tables: property, data mart, automobile, commercial. Now I have to choose. I mean, the table can be in the data mart. The table can be called. Now we are totally in a granular level. We move to the tabular. I mean, we are over here. We have the data. Now we have to store the data inside the table. The table that we have already gone through over there with the create statement by DDL and pushing the data there. But the tables should be two types in nature in data mart. One is called fact, another one is called dimension. Okay, so fact table should contain fact data. Dimension table should be contain dimensional data. So what is fact data? What is dimensional data? We need to know that thing. Otherwise, we cannot segregate within the data warehouse. We cannot able to. Suppose our manager or our tech lead told create a dimension table and put those dimensions, those dimensions. Then if we are not aware, we can create the table easily by the SQL. But which particular column I need to take from the data warehouse? That is, I mean, we are quite upset on that one. Even that information also should be shared by our team lead or just like this. But you should have this minimal knowledge what is fact and dimension. Then that should be quite easily understandable. You should be having questions that why I am collecting these many columns into that tables only. Why I'm not including another columns over there. So that can be helping us. Okay. So first of all, what is fact? Fact is, I mean, if we questions on top of data, so how much or how many, this kind of stuffs. Whatever we are receiving answers, those are called facts or measures. Okay. So fact measures, those are the same thing. And it should be numerical in nature. Generally, it should be numerical, just like sales data. Okay. What are the number of customers that particular sales has been occurred? So those kind of information, fact and dimension, I mean, a fact should be storing, just like revenue, cost of a particular product, number of accounts. The numerical values are mainly specially called fact. Not all the numerical should be fact, or maybe the vice versa thing is also correct. Fact can be non-numerical as well. I'll be coming to this point quickly. So those fact information can be stored in fact table only. Okay. So the particular thing you can say sales billing. Inside the sales table, the red color highlighted field or columns. This is a table, and inside this table, those are columns. So you can see integer, 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 float, float. Those are the data types of the column. The below four columns in the sales table, you can see those are numerical in nature, and that can be help us with answering how much, how many, those questions. And top three columns, those are not in numerical, but those are required in fact tables. I'm creating the fact tables, but inside the fact tables, all the stuffs are not facts. The below four columns are for representing the facts, and the upper three columns are non-facts. Those are key in nature. So they can be primary key for the table, and they can be foreign key as well. If you could remember at the beginning of the session, I have gone through what is primary key, what is foreign key, and those are very much important now. Now we can see what key roles they are representing. So for sales, there should be a primary key for that table. We need to create that one, and there should be lots of foreign key because that particular fact table can be connected or will be joined with the dimension table. So all the dimension tables primary key should be a foreign key over here. Just like store key, product key, date key. Those are the foreign key actually. I do not put the primary key for the sales table. Rather, I put all the foreign keys from different dimension because only a single fact table is not will be solving your problem. There should be dimension table as well, and dimension table should be having their own keys or their own primary keys. And how to set the connection, we already checked that we know the join criteria, how to join, how to inner join, how to do the left outer join and all the stuffs. So we have to put those keys over there. Sorry, am I audible properly? I can see my internet connection is unstable. That's why I'm asking. Can anyone just please tell me whether I'm audible properly?
Yeah, you're doing.
Okay, just I seen some pop-up message that your internet connection is unstable. That's why I'm asking. Okay, thanks for confirming. So this is a fact table, and the fact table, the upper, the first columns, those should be conventionally. Not necessarily the first column should be there, but as per the convention, it should be good in nature. The first few columns should be keys, and those can be the foreign keys by which we can join with the dimensions. Dimension table. So I'll be coming to this topic, what is dimension table and all. But this is for the same thing for the billing as well. Okay. So the red color highlighted, those are called facts or measures. And inside the fact table, we can store the foreign keys of the dimension tables as well as the main facts. Okay. Okay. Moving on to the next topic. What is dimension? Okay. Dimension is one of the most important stuffs as well. So it should be answering the question who, what, when, where, those kind of stuffs. Okay. And also we can say dimension is a master data. So just like customer, we are storing customer information in somewhere. So we can also say fact table should be very much larger in size because daily basis transaction should be there. Maybe a particular customer came today and he came, I mean, he should be coming tomorrow as well with some particular product. Okay. But the particular, I mean, the customer list should be same. In the particular customer table, we should be only storing customer information. Maybe we have a particular country dimension table. Okay. Suppose we have product dimension. So maybe daily basis, the product should not be updated. Maybe today I did not inaugurated a new product. Okay. So the product dimension table is fixed. So we can say rather the dimension table should not be frequently changing. Okay, just like store. Store is a particular table which should be collecting information of just like what is the city, state, region, country, what is the street address, store name, and this is store key should be a primary key for that particular store table. Okay, and you can say in the fact table we have a store key there. So to connect with the two table, to have the join between two tables, we need to create the foreign key over here and a particular, I mean, sorry, a foreign key over in the fact table and primary key in the dimension table. So this should be the normal convention because we need to keep our tables uh, in, I mean, degenerating mode. Also normalization, it should be normalized in nature. So I think we have already have the concept why we should keep this normalized and why the normalization is required. I have covered it in the second day of this season. So that's why it's very much important. We need to keep those keys available for each dimension and fact table. So those are the overall concept. Just like product, we will be storing all the product information, the product serial number, product name, product group, what is the brand. Okay, so that's why we may be having some date, dimensions, and all, and this kind of stuff. So those are the all information for today. So today what we created fact and dimension inside a data mart. Okay, fact and dimension is nothing. Those are kind of table. What kind of table we have created over here in our MySQL? The same kind of stuffs are there as well. So just like we need to maintain this thing in proper way. While creating the table, maybe we do not maintain proper keys or proper foreign keys there. But while storing the thing at the data mart, we need to keep this thing in mind. We should be guiding from our team lead or team architect what should be the columns for this table, customer table, what should be the columns, For a fact table, what should be the columns that can be represented by our, of course, our team lead or any other one, the team architect. And by the same way, we need to create those tables at our own. We need to populate the data. We need to set proper business logic for population of this fact and dimension table. Okay. So those are the all for today. And this is the main thing. That's why we are here. I mean, the data engineers are here for storing those information inside the meaningful tables, doing all transformation, all cleansing operation, all the stuffs. Okay. Any doubt till now? Okay. Hopefully no. So tomorrow I'll be, yeah, someone Varadvaj.
Yeah, actually, I want to know, does this BI makes impacts on decision making, like in organizations?
Yeah, actually, if we are not, uh, I mean, properly done, somehow maybe our architecture is wrong. They did not create proper way. Uh, Suppose we did not create proper way the data mart. Okay, so tomorrow we'll be learning the data modeling part. There is a cardinality, we can say. Suppose we need to set up the cardinality. We have the dimension table for customer. We have the fact table as well. We do not set proper cardinality, and the particular things are duplicate in nature as well in the table. So when the graphs is prepared on top of this table, then we can see that the graphs is not showing the proper value. Okay, it may be duplicated or it's maybe showing a larger revenue, which should not be the scenario. Maybe a particular transaction has been captured twice over there, but in exact scenario that should not be twice. Okay, so if the data engineers do not perform quietly well, or maybe the architect did not give us in proper information or proper way suggestion, if there is some issue at the architectural part of this system, then whatever data we are preparing to the business, I mean owner or to the decision maker, they will not take proper decision actually. So that should be a huge loss, of course. So that's why the thing should be having it a good way, or maybe kept in a clean way. I mean, the data engineers is playing the key role over here to prepare the data in a good manner. Okay. So tomorrow onwards will be not tomorrow onwards, actually tomorrow only. The second day of business intelligence, I'll be taking those facts and dimension, and we'll be creating the data modeling. And the data modeling should be passed to the visualization team, and on top of the data modeling, they can create those charts and graphs. So tomorrow we will be learning these stuffs, and quickly learns about the visualization perspective as well, some popular charts and graphs, and some of the quick properties on top of their charts and graphs and all. And yeah, so today we do not have enough time. Maybe tomorrow I'll be checking the another example to have a quick hands-on. Maybe if not possible as tomorrow as well, the day after tomorrow, maybe Friday, it should be surely done. Okay, with some free time, and maybe I'm assuming Friday I'll be starting the Python with some installation part and all. So there will be lots of time left to cover up this one. Okay, so that's all for today's session. Let's catch up tomorrow for the second session of BI, business intelligence. What I'll be doing for using those fact and dimension, and what are the separate dimensions available, what are the business strategy we need to implement for some of the slow changing dimensions and all. Some technical stuff should be there as well for tomorrow's session. So let's connect tomorrow. Okay, for more details. Thanks everyone. Bye bye. Have a great day. Okay, I received some questions. Sorry, let me check. Okay, Shreyasi just been. Thank you. Okay, yeah. Thanks. Bye bye. Have a great day.